Here we have a SAT math question. Okay, let's go with the information. Here we have an equation that is k equals to 1 half times mv square. The equation above gives the kinetic energy k in joules of an object as a function of its mass m in kilograms and its velocity v in meters per second. And the experimenter is comparing the kinetic energy of two objects. The first object has a mass of m kilograms and a velocity of v meters per second. The second object has a mass of 4m kilograms and a velocity of 3v meters per second. Which of the following could represent the ratio of the kinetic energy of the first object to the kinetic energy of the second object? Okay, now let me assume K1 as the kinetic energy of the first object and K2 as the kinetic energy of the second object. Then this K1 over K2 gives the ratio of the kinetic energy of the first object to the kinetic energy of the second object. Now let's get the kinetic energy of the first object, that is K1, using this formula 1 half times mv square. For that we have to plug in the mass and velocity of the first object. So the question says the mass of the first object is m kilograms and velocity of the first object is v meters per second. Then we have to plug in m and v. I mean m for mass over here and v for velocity over here. Then we'll be getting the same stuff for the kinetic energy of the first object, that is K1. Let me write the stuff over here. 1 half times mv square. Okay, now let me write the kinetic energy of the second object K2 using the same formula. And the question says the second object has a mass of 4m kilograms and velocity 3v meters per second. So to get the kinetic energy K2 of the second object, I have to plug in 4m for this m over here and 3v for the v over here. So let me write the kinetic energy K2 for the second object, that is 1 half times. For m, I have to plug in 4m, and for v, I have to plug in 3v. Since the velocity has to be squared, this entire 3v has to be squared, because 3v represents the velocity of the second object. Okay, now we have to simplify this one. This 1 half and 1 half can be cancelled, and also this m and m can be cancelled. Now we have v square in numerator. In denominator, we have 4 times. And this 3v squared, that is 3 and v are multiplied, and we have the common exponent. Whenever two terms are multiplied and we have the common exponent, the exponent can be distributed for each term over here. So then I'm getting 3 square times v square. So this v square cancel. That is v square goes into v square 1 times, v square goes into v square here 1 times. Now we have 1 in numerator divided by 4 times. The value of 3 square is 9. Then I'm getting 1 over 4 times 9 is 36. So the ratio of the kinetic energy of the first object to the kinetic energy of the second object is 1 over 36. I find this 1 over 36 in answer choice A. So the correct answer choice for this question is A.